This video covers section 11.1, Composite Functions and Inverse Functions. Objective 2, determine whether a function is one-to-one. Recall what a function is, and then we can talk about the further restriction in order to be one-to-one. A function is a relation in which each input or element in the domain corresponds to exactly one output in the range. They can go to two different inputs, can go to the same output, but there can only be one arrow coming out of each inputs. We use the vertical line test to see if something wasn't or was a function. Now, a one-to-one function has the property that each output corresponds to only one input. So the function is each input goes to one output, and now the one-to-one functions have the property that each output corresponds to only one input. This is so simply stated when you see this picture here. One arrow coming out, only one arrow to the y value. One in, one out. So it's going to be one arrow, two, and then we can go back from that same one because it's always a one-to-one. So one-to-one function has the property that each output corresponds to only one input. You can see why it's called a one-to-one function. This function has the property that each input corresponds to one output, and each output corresponds to one input. This gives us the idea of you give me an output and I'll tell you exactly which input it came from. We can't say that when there's two arrows going to the same output because we can't say which exact one gave us that output. Some examples of functions that are not one-to-one: when you have dog and cat going to the same life expectancy, or -1 going to 3 along with 1 going to 3, or -2 going to 6 along with 2 going to 6. Even our simple parabolas, 1 goes to -3 and -1 also goes to -3. These aren't one-to-one functions as well. So to determine if a graph is a one-to-one function, we see if every horizontal line intersects. Now it's a horizontal line test for one-to-one. Intersects the graph of the function only once. If a horizontal line intersects the graph of a function more than once, the function's not one-to-one, just like our parabola. So here's a practice problem for you to try. Use the graph to determine whether the given function is one-to-one. You probably have your guesses by now. Letter A is going to pass the horizontal line test. So this, yes, is one-to-one. Now something like this passes through 3 spots. That means all 3 of those different x values will go to the same y value. And so no, it's not one-to-one. It's a function, but it's not a one-to-one function. And so again, the one-to-oneness of it allows us to say, you give me an element in the range and I'll tell you exactly where it came from in the domain. And you can only say that if it's one-to-one. And this concludes the video for section 11.1, Composite Functions and Inverse Functions. Objective 2, determine whether a function is one-to-one.